record this one because I recorded one earlier, but I found a neat utility tool, like a neat graphing calculator tool. But go ahead and still write this down. Remember, just stop where it's straight down, because I want to go ahead and expand on a few points. Yeah, you don't have to write it like that. Break down one letter at a time. What I will ask you all to do, well, let me go ahead and explain how this came about, because some of y'all might be looking at it and might recognize like the A, the C, the H, and the K, but are wondering about the rest, especially like the F. How many people have ever seen that F before? Well, you know what? You've probably seen it. It's just that it was placed in such a way that it makes it hard for you to recognize what it is. And let me go ahead and show y'all what I'm talking about. How many of y'all were introduced to f of x and they told you y equals f of x? You know, most of y'all, they started that way, right? They said y equals f of x. Now you might be wondering, well, where does all this stuff come in? You know, where does these a's, these e's, and everything else? Where is it as far as f of x itself? It's actually present in it. Okay, first of all, there's a 1 in front of the f of x. There's a 1 in front of the x. And I'm writing all the identity values. Like if you notice how this is like multiplied, this is multiplied, the identity value is 1. The identity value for addition is 0. And 0 again. Now, when they go ahead and break it down and say what does all these numbers or identities have an effect on the graph, in essence, this is what they're doing. This 1 is the A, this is the F, this is the C, this is the X, this is the H. Actually, most of the time they put it as subtract. Let me fix that so y'all can see that. You can put that as a subtract too. It doesn't matter. When it's an addition, it's really negative, but it's minus H plus K. So it's exactly the same one you wrote down. It's just that we're talking about in the context of the function itself. Does it make sense now? That general equation was the one that now we're still talking about this f of x that's up here. But now we're talking about it if there's an A, a C, an H, and a K. Add it onto it as far as in itself. Now let's talk about each of them and the role they play. That's probably what's more important to go ahead and discuss. Let's discuss. There we go. Okay, the role of H. Now H is probably one of the most important ones, and we find out that you will find H inside, kind of like similar to what I showed you on the last one. H is inside being subtracted from x. This means that it will be under a square root, a cube root, in the parentheses, or inside the absolute value, depending on your equation. We're going to select the value. Now, don't write the last bullet where it says select, but write the first two, because we're just going to select it. All right, excellent. Now, it looks like most people are almost close to finishing. Now, I'm going to show y'all a kind of a neat little website in case if you don't have a graphing calculator at home, like one of these TIs, and you kind of want to see what some of the transitions it has on it. If you go to this website, has everybody done writing? Oh no, we have maybe one or two other people. Let me just hold on for a second. But this is a great resource. So one of the important things you could go, if let's say you're at home and you don't have a graphic calculator, but you have a computer, okay, you can go to this website right here. It's called Desmos. Everybody see right here, Desmos? Okay, you can write it down, or you could just type in Google graphing calculator, and this one will come up. Now, the reason why this is kind of neat is that it's pretty simple to use and it's pretty quick. Now, for example, let's say I do the function. Let's go ahead. I'm going to use the example, the parent function x squared. Oh, it's writing. Let me clear this, and let me actually use it to type. Okay, x squared. Okay, we all know that it's this parabola right here, right? Okay, now we're going to go ahead and apply the actual h value, and we're going to do it by doing -4. So I'm going to go ahead and add in another expression. Now, look at the way it's written. Parentheses, x minus 4. And then I'm going to go ahead and come to the outside because I'm going to square it on the outside. Do you notice that the squared is not on the inside? It needs to be on the outside of any parentheses in order for it to classify as that h. But now notice what it did. Okay. If you notice what it did, it shifted my graph. And it shifted it to the right 4 directions. So that's one of the things when I added the negative. Now let's see what happens if I change this over to the positive. What do y'all think is going to happen? Yeah, it's going to shift it over to the left. So the transformation that actually occurs is going to be it translates it to left or right. That's really what it does. So what I want you to write down is this. I want you to write down that h shifts your graph to the left or right. To the left if h is positive, and to the right if h is negative. Now don't write the be careful part. And the only reason why is that all they're saying in the be careful part is they're saying that it's going to be opposite of what you see. It's really what they're trying to communicate to you. So don't think it's a direct thing. If it says -4, it goes the opposite direction. So really, all the careful part is trying to say is that it's not a direct thing. You see -4, it's not going to move to the negative direction. It's going to move the opposite direction. Now let's go ahead and explain. Now talk about the second most important translation. Some people think it's the first. It just depends on who you talk to. It's the role of k. K actually is you'll find k on the outside, so it's very easy to identify. It's a very easy function to see, or actually, it's very easy to identify where k is, because it's going to be on the outside, and normally at the end. Now just write down, don't write down the select part, you just write down where you will find k. Now we're going to do the same thing. We're going to add 4, we're going to subtract 4, and see what it does. Now for most of y'all, if you had a good Algebra 2 teacher, you probably know what's going to happen before I even type it in. Now I'll go ahead and type, I'll type in +4 on this one. Y'all see what happened to it? Moved my parent function. This one I'll go ahead and hit -4. So this green one is the one that's going to be affected. I hit -4. Y'all see how it's shifted it down for? So the nice thing about the k is that it's a direct variation to it. Direct. That means that if it says +4, it's moving up 4 vertically. If it says -4, it shifts down 4. So the conclusion is this. This is the important part I want you to write down. K shifts your graph vertically up or down k units. Up if k is positive, down if k is negative. It's easier because there's no additional things. It's very direct. Lovely. Now let's go ahead and talk about the other value, and now we're going to move into the next one that's most common is the a value. And the location of the a, you'll find a multiplying the outside. It's going to normally be right after the equation. So after you see the equal sign in your equation, that's how you find it. So just write the top two bullets. Don't write the select because we're going to go ahead and practice those in a minute here. Now, just the first top bullets. Let's explain. Let's go see what happens with the a value. Now the let's see where is. Let me bring back my radar calculator. Now what I'm going to do here is I'm going to shift. Let me delete this one, and this one I'm going to go ahead and make it back, like neutralize its effects. And what I mean is like that normally would have been 0. This normally would have been 0. The a is the one that's on the outside. Okay, like in this case, and that's normally where it's going to pop up. Right now, I just have the parent function x squared because I just put the identity values on all the rest, including the a. The a currently is 1. I'm going to change that to a decimal and see what happens. Now, let's say I did 0.2. Does everybody see what it did? It made it wider, exactly. It actually is called a compression. It's called a compression vertically because what it's compressing is the x values of the function itself. It's compressing, that's the effect that it's having. Now, as far as, I'm going to go ahead and now change that and now make it into a number that's bigger. Right now, I just went ahead, you see how I deleted everything? It automatically, the system made it into 1 again. It brought it back to identity. A is 1. Let's change that to 5. Now, y'all see what happened with it? Yeah, it's considered to be stretching. It stretches it, and really when it stretches it on the y, what it does to it in essence is that it's making it appear narrow. So this is what I need you all to write down. This is one of the things that you do need. And now the important part is you got to keep an idea that it's having these effects vertically, or in essence, the y values. And it's really saying this in the y values. Vertically stretches or compresses your graph. So anytime you see the word vertically, you could think about y values too. Compresses your graph, y values, making it appear wider. Stretches your graph vertically, y values, making it appear more narrow. Oh, the other one, only one we didn't do on there, and we'll do it right now, is the last one. If a is negative, it reflects the graph over the x-axis. That's actually probably the more common one you're used to seeing, reflection on the x-axis. Because it was actually quite frequently you would develop an a that's negative. Okay, good. Now, let me show you an example of the last one because it is something that does come up. Now, the good thing is that I know that this is not the first time you've seen this. So that's a benefit. That's a plus. Yes, let's see what it does. Now, all I'm going to do is going to put this a negative in front of it. Y'all see what happens with the negative? See how the reflection happens? That's something actually you're probably custom seeing. So it's not that bad. That's probably something you're custom seeing. The other kind of reflection is actually more interesting. That one you're not so custom seeing, but let's get there first. Now, where does that happen? It happens right here. It happens when the row of C. The C is located in front of the X inside the parentheses. So it will be inside of any absolute value, square root. That's how you identify C. Just write the first two bullets for your notes, just the first two bullets. Okay, excellent. Remember, just write notes for the first two bullets. So when it says it will be inside the parentheses, we're going to stop there. Now let's actually see what happens with that C value. So I'm going to go back and I'm going to neutralize, or I'm going to set this thing back to its parent function, which is 1. And I'm back to the parent function. All my A's, everything else, it's identity, so it has no effect to it. The C is right in here. Does everybody see where the C goes? Okay, I'm going to start first with the fraction. And we're going to go ahead and describe what it does. So I'm going to start with 0.2. Oh, wow. Y'all see what happens? Okay. Yeah, this is described as a stretch in the horizontal direction, but in the horizontal. So it has some different terminology, okay? And let's change this. Let's go ahead and now put the 5 in there. Okay, this one is actually called compression in the horizontal direction. Now you might be wondering, Mr. Sandoval, you're talking about this being compressed. How is it compressed? Let me go ahead and explain just a little bit. It's going to be a little bit, you will have to really think about it to understand the terminology behind it. But in the quick sense, when we're talking about compression, since we're talking about it being horizontal, the compression is actually coming from this side. All these values are it's compressing it from the original parent function. That's why it's called a compression to it. The idea behind that means that when we talk about C, we're going to have these effects that I need you all to know. C horizontally stretches our compresses the graph. When the C is bigger than 1, that's where that compression comes in of the graph. Horizontally making it appear more narrow. And when C is a fraction, it stretches your graph in the horizontal direction, making it appear wider. Oh, and then, you know what? We'll do the last one too. C is negative. But not now. Write it down, and then we'll do when the C is negative. That one's probably the most interesting one out of all ones. Be excited when we get there. right, now let's actually talk about the one I said I was excited to do because it's actually interesting. Now there is some people writing, so I'm just gonna wait a little bit, and then I'll talk about the exciting. Now the reason why I find this one exciting is because it's not very common. It's like one of those like, oh, I always wondered how that happened. I always wondered, how that occurred. Now let me delete this. Let me go back to the writing mode. Now I'm gonna use. Let me take this one away. And I'm going to use this. I'm going to use actually a square root and place the x in there. Y'all see that? Okay, lovely. Now I want you to think about this. How many people know how to reflect this across the x-axis? Yeah, reflect this equation across the x-axis. Well, yeah, what transformation? Yeah, flip this one across the x. Like this one. What would I do? Yeah, which one? What would you do? Yeah, I know, but what I need to do to the equation? What needs to be changed or typed so I can make that negative where? On the very front. Okay, yes. Actually, that's very right. Okay, so we got a negative there. Flex it, right? Okay, lovely. What about if I want to reflect it not like that, but across the y-axis? Actually, you would think, but actually that doesn't work. You would think, but that's actually not. Yeah, on the inside. That's exactly where the C value is at. Inside the C value, where the C is right now, it's 1. If I made it into a -1, then it does that. Everybody see that? So that's the interesting thing about C. That's the part that I was like, you don't see this often, especially the idea of it, how it happens. So what I want y'all to do for the rest of the period is go ahead and bring out the assignment y'all picked up, number 6. I want you to work on that. We'll discuss, I want you to get most of it done. Hopefully, well, you'll get a good portion of it done because you have about 20 minutes left. I'm going to go ahead and pause this. Now, remember these videos